No. Hello, everybody. We are in the last workshop for today and for all the FoF 2022. Well, let's move with Marcelo. So go ahead.
Thank you, Letty. Hello, everyone. Nice to see you again. Thank you for joining this very last hands-on session. So, have you been able to try the tools that I showed the previous session?
Yes.
It's okay, no problem. Just a little comment to make you feel uncomfortable for a minute. Okay, well, I hope I will add some, well, for example, the presentations, this presentation, and some code and some material to the repository, to the GitHub repository, and also maybe to the Discord channel for this activity. So stay tuned because I will try to give you some material as soon as possible. So in the previous session, we were talking about some revelations that I think I've discovered during my career so far, and I think could be very useful for everyone. And also my friends in the organizing committee asked me to talk about something about plots. I think it was never perfectly clear for me, but I will try something. Okay. So we have 3 revelations to go today. As a quick review, the first revelation is that we all know that we need some method or something to improve our production as scientists. So sometimes maybe a tool or maybe a tip or a trick or a method can help to do it better. The second revelation is to organize our work in a tree. There are some tools to do it. The third revelation is to organize your tasks and your time, and there are also some tools to do that, as we saw. It is very important to use version control because it could happen that sometimes computers fail. Sometimes we are working with not too much inspiration sometimes. So we can delete files or we can change something that we regret later. So version control is very useful to avoid problems. Okay. Settings files are very useful to organize experiments. It is a common task to carry out several experiments with different parameters. It is very common in the way we work. So saving the settings files allows us to maintain a track of the experiments that we have realized. And also there are some tools. For example, I show you the ML flow that gives some automation to this process. And very fancy maybe and very useful. And this has to do with reproducibility of the experiments that we are performing. So the next revelation is do it with style. What do I mean with style? Well, when we make plots, there are different configurations or different styles that are meant to different sources. For example, it's not the same a plot intended for publication than a plot intended for a presentation, for a talk, for example. So I think it is very useful to maintain a repository of settings for the plotting. I nowadays use, for example, matplotlib in Python. So I will show you some tricks to write better plots with less lines of code, because you can put all your preferences in configuration files. So some key concepts are that if you are making a plot for a publication, we as professionals should maintain a minimum standard of quality. For example, it is better to maintain the same style for all the plots in the paper. Maybe if you see a paper with a lot of plots with different styles, for example, one with a very large font, one with bold font, and one with a very small font, and so on. It is not very pleasant to read. So the feeling when you read a paper with a uniform style is absolutely different. Before you start, it is very useful to define the color palettes. Color palettes are the set of colors that we are going to use in all the plots, not just one plot, but all the plots in the paper, or all the plots in the thesis work, or maybe all the plots in all our papers, or whatever. It takes some experimentation because with time, a person is changing the taste for making plots and discovering new tricks and defining the style that one wants to produce. So color palette includes, I always say 6, 7, 8 at most different colors. And one aspect that we should take into account is that these colors should be colorblind friendly. There are some pages that can help to define if a given color palette is colorblind friendly or not. And this is very important because the resulting plots can be more inclusive, because anyone can understand the results. And also, it is very useful to use styles efficiently. And this has to do with writing the style just once and then using the same style every time we want to make a plot. So there are tools, for example, the RC parameters in the matplotlib library. RC stands for run, and the C is for, I just forgot. I would say settings, but it's not with C. But this is the idea. You run something, and automatically the settings are loaded from somewhere, and the result is always with the same settings. So there are several options. For example, you can use runtime RC settings, or temporary, or you can use style sheets, or you can use custom style sheets, or you can use a configuration file. From my point of view, see, for configuration, yes, it's pretty obvious, isn't it? Right? I think you're right, Fede. So I prefer these options in this order, right? Because of the following. if we use the settings for a single plot or for a single instance in the work we are doing, then can you see the mouse? Yes. Then we need to set the options every time. And if you generate a different file to make a plot, you have to write these parameters all again, right? So this is an option. It is possible to work like this, but I think there are better ways. Another option is to use a temporary configuration or a temporary setting using the with command in Python. So everything you put here affects the plot which comes within the with environment. In this case, we also have the drawback that if we make another file to make plots, then we need to reproduce these all again. Another possibility is to use the predefined styles in Matplotlib. For example, ggplot or there are something like 20 different styles. You can explore the different styles and pick the one you find more suitable for your intentions. So this is, I think, a better situation. And even better, this is the one that I like. You can use you can use your own personal style sheets. Okay. For example, you can store in a given directory all the styles that you are intended to use. For example, styles for papers, or styles for presentations, or styles for talks, and so on. In these styles, you can set the different values that you prefer for that situation in particular. Before going to something different, which are the LaTeX tricks, I will show you in practice how to use these style sheets. Maybe you can work with me and try at the same time, or try later. I don't know. So let me open the terminal. I will change the transparency. I'm sorry, I have to do this all times. Right. So I have here a file which makes some plots. Let me show you very quickly what is this about. It's a demonstration of a numerical method. Okay. So it does some things, but the important thing I want to show you is this function. I made a function called setStyle. Okay, and this function uses a tools file, and this is simple like this. I will pass by command line a word, for example. This word can be, sorry, this one, vivid, pastel, favorite for the colors, and can be web or papers for the sizes of the elements in the plot. So when I call the script, I can pass these words as arguments, and according to that, I will load different configuration styles. So in one case, I load colors vivid, for example. In another case, colors pastel, and so on. Let me show you what is this about. Colors pastel, right? It's just a list of colors, that I made using my preferences and using the help of pages to construct color palettes, so on. It's just a list of colors, and this option is part of the options of the matplotlib library, right? There are other preferences, for example. Let me show you this one, which is a little bit more complex. This sets all the sizes of the elements of the plot to make plots that are publication compliant, right? So I set, for example, I'm sorry, the size of the figure, the width of the lines, the size of the marker, the size of the text, the font. You can select any font that you have in your computer. Maybe there are some portability issues if you are using this configuration file in different systems, but as long as you ensure that the same font is present, then there will be no problem. And in any case, the default font will be used. So there are a lot of options here. These are all the options that I have set up for making publication quality plots. Okay. And there is also another file, which is this one, matplotlib.rc. This is a file which is distributed with any Python distribution, right? Originally, it is commented for all the lines, absolutely all the lines. But you can make a copy of this file. For example, if we look for this file, you can see that there are many instances of this file. For example, this is a backup. This is the one using in a virtual lamp. This is another virtual lamp, and so on. And there is one. Okay, in this case, all the instances are part of virtual environments, because the only installations of matplotlib that I have in my system are part of virtual environments. So you can take it any one of these. For example, let's see this one. As you can see, this is the original version of the file. It is commented for all the lines, absolutely all the lines, right? You can see the hashtag at the beginning of every line. So it is commented in all the cases. So I made a copy in my directory, and I can edit this copy, put out the comments, and change the values. So if you do nothing for a plot, I mean no options whatsoever, so these options are going to be used to produce the plot. If I run the script without options, then these options will be used to produce the plot. And the good thing is that the style sheets can be combined. So if you load a style sheet and then combined with another, the last loaded file will step over the previous ones. Okay. So you can use always the same configuration file and replace some options if you need it with another file. So far, we have this file, which is the standard one, and I have these MPL style files with different styles for different situations. Okay, so we're going to use these configuration files for the style to produce some plots. So let's say we run the script, which is called animate. Oh, I'm sorry. I should load the virtual environment. Okay, Python animate. Then a plot is produced with certain options, right? Which are the default options. But I can do the same thing with web, for example. Remember, web was one of the keywords that I want to use for the styles. So if I use web, the plot is a little bit different, and we just change one word, okay? And I can produce the same plot for a different purpose, right? This is a plot intended for a web publication with a different font, different width of lines, and so on. And I can go for the papers style, so I get a different option for the plot. I have worked with the options in the papers configuration file with a great effort, because with these configurations, this plot looks very good in a monthly notices publication, for example. Let's say I save this plot. I'm saving the plot as plot PDF, right? So you can see here. When I show this script, it's saved a file called plot PDF. Okay, and then I go to another directory, which is MNRAS for the monthly notices template. And in this template, I have included the plot PDF file. Let me look for it. Include. Sorry. Here it is. Plot PDF is the same plot I am producing in another directory. So let's make a compilation. And here is the plot which we just produced. And with the right choice of sizes and colors and so on, I think that this is a very good option for a publication quality plot. I have paid attention, for example, for the fact that the size of this text and the font is exactly the same that the size and the font of this text in the caption, right? And how did I do that? Because I have chosen in the papers style this font, the Nimbus Roman font, which is very, very similar to the font used by monthly notices. And the sizes for the labels, for example, it has to be taken into account that there is a relation between the size of the labels and the size of the figure. If you change, for example, the size of the figure, then you will have to change also the size of the labels accordingly. Okay, but anyway, since PDF files are vector files, you can change the size of the file, and you will not see any problem in the rendering of the figures. So any size here is okay. The only thing to be careful about is the relation between this size and the size of the figure, right? For example, if I put, I don't know, 3, a very small number, then the size of the plot will be smaller. right? And then, since the size of the caption is the same one, the relation between both will change a lot. Okay, so this is the only thing we should take care. So 10 and 10 is a good option for this case. Oh, sorry. So there is another trick I want to show you, which has been very useful for me in order to make plots which are not very easy to produce with the standard tools, for example, R or Python or the one that you're using. So if you produce a PDF file, you can edit the file with your hands using, for example, a program called Inkscape. Vanessa and Fede know about this. I use it a lot, and I am always talking about this. So I'm going to show you very quickly how to work with this tool. So let's say we open the file with Inkscape. Okay. So this is the original plot. It is not the best version because the relation between the size of the labels and the plot itself is not very good. So there are a few things that we need to know about this program. The first thing is that everything is a vector, right? It means that you can make zoom, for example, and you will not see that the curves in the details are pixelized. Okay, so actually, since this is a font, some interpolation tricks are used internally by the program, so that this looks always the same, no matter how zoom you can do. Okay. So another thing is that you have layers. Okay. Here, one of the options in the menu is layer. Maybe it's a little bit small. Just tell me if you need to see it better. But the advantage of layers is that you can have in the same file different versions of the same plot. This is very useful because sometimes you need to present a plot, for example, in a talk, but considering different parts of the plot. Or you need, for example, modify the plot, the colors, or something. And it is very easy to do it with this tool. So let's make a new layer. Just add a layer. Okay. This layer will be called plot 1, whatever. That's okay. If you open here, there is a menu here at the side with the different layers. And there are two options. An option to see it or not, and an option to allow edition or not. So what we are doing here is to make a copy from this layer to this another layer. Okay, and I will change some elements in one layer and not in the other. So I will oh, I'm sorry, let me just here. maybe you need to know some shortcuts, but the idea here is to show the possibilities of this program, not exactly how to use it, right? So in this case, maybe I want to change the color of this line, turn it to red, for example, and the colors of these lines, just click over it and click on the color, okay? You can put, for example, a different color for each one of the lines. So you can see different colors here. It's very easy to do it. And then you have two versions of the same plot. One version in one of the layers, this one, and the other version in the other layer. And you can change very easily from one layer to the other, and you can save the plot from whatever version you prefer, right? It's very useful. Maybe it takes some time to learn the keyboard shortcuts to work with this program. You can do it everything with a mouse, no need for a keyboard, but it is more efficient using some shortcuts from the keyboard, right? So I like this tool, and I recommend to use it because it is very useful, I think, uh, to producing high quality plot. Even it is possible, for example, to make something like this, right? You have two plots, and maybe you can make, I don't know, arrow, for example, from one region to the other. Let's make the point of an arrow, not an arrow, right? So something like this, for example, is very difficult to be made with Python or R or anything, but it is very easy to do it here. So I think the best combination of all the tools is to make a very simple plot using your preferred tool, that can be Python, R, or whatever, and then make a small edition with Inkscape in order to make comments or add certain elements to make the plot more understandable, right? You have to be careful, however, to not change some key elements of the plot that are that need to be the way they are in the original file. For example, you cannot do this or this, right? Because there is something missing here. So you need to be careful about that. But the result is very nice, and I have used this tool for several papers, and the results are very good, and the referees are always happy with the quality of the final plots, at least in my experience. So this is a very useful trick, I think. Another trick I want to show you is one related to LaTeX, also known as latex. We say latex and no, not LaTeX, but this is the way it is. There are some packages, for example, Tixeta, that allows you to make, for example, flow diagrams, even plots. I do not recommend making plots using LaTeX. It is possible, but it is not nice. So the results are not so good. It is very complex to make a plot using LaTeX. So I would recommend make a PDF plot using your favorite plotting tool. Edit them using Inkscape if necessary, and then put the plot in the final paper. Some examples of what can be done with LaTeX are, for example, this one. I took this portion of text from a draft we are making with some collaborators, including Vanessa. So with this and the definition of my bar, which is here, my bar. Oh, I lost my bar definition. No, here it is. I made a new command, my bar, which allows to introduce a number in a table and a color bar in the same table and in the same place. Something like this. Okay, so you can you see the colors here? They are somewhat faint. So you can create tables or histograms and tables in the same place. And there is no need to produce a table on the one side and a visualization of the table on the other side. Right? It is not very easy to do it, but with a little dedication and time, you can do it. This visualization and some other visualization that are very, very useful. So here, for example, we need to say the number to be plotted in the table, the reference number, which is the maximum number allowed for this category. For example, if it is a percentage, we use 100 here. And the number to be used to plot the length of the bar. Okay, so almost in all cases, the name is the same, right? For example, here I use the exact name, the exact number, sorry, for the plot of the bar, and a round of that number to be written within the bar, right? So this is a very nice option to be made with LaTeX. And another option is to draw flow diagrams. Sometimes we need to explain, for example, algorithms or a pipeline, or for example, for a reduction of images, or a pipeline for some theoretical work or something. And then it is possible to make these flow diagrams directly in the LaTeX file. For example, you have to define with a Tixita style a given element, which are called a node for the flow diagram, with some options. And then here is how you can produce the flow diagram, which is something like this. Okay, this is a flow diagram, right? Each one of these elements is called a node. So you will make first the different nodes and then connect the nodes with arrows. Okay, here we can see the nodes. Each line here is a different node. Some nodes are of the type block, for example, the initial one here. And some nodes are of the type cloud or decision, for example. The decision if this one. Here we have a decision, right? This diamond shape node. Okay. So we give them we give each one of the nodes a name, a nickname, and the text that is going to be shown within the node. So, for example, in the initialized model, we have a nickname called init, and in the expert node, we have a nickname called expert. You can see here the expert node and the initialized model node with the nickname of init. Then, in order to draw the arrows from one node to the other, you will have to make a path, right, of the type line between init and identify, or between identified and evaluate, and between evaluate and decide, and so on. So the final result is like this, right? Sometimes the arrows are continuous, right? And sometimes are dashed. You can set those options. This resulting flow diagram is also a vector, so that you can make an infinite, in theory, zoom, and you will never change a resolution in the resulting flow diagram. Okay, so these, I think, are very useful tips to make high quality plots for publications, and taking advantage of the style sheets, for example, that allow you to achieve better results using less lines of code. So this is the 8th revelation. Make the plots high quality as long as you can, because when you see a paper, it is evident when a plot is of high quality or not. And if the plot is not very good, then the feeling of the referee is that you didn't put enough effort to do it, right? At least that is the feeling, right? It cannot be true, or yes, but the first impression from the plot can be different. And the last revelation is that no matter what you do, what tools can you use, or what methods, and so on, but the most important thing is the data you're using. So one of the most popular roles today, both in science and in the industry, is the data analyst, for example, or the data scientist, or the data engineer, or the data architect. And the data is the first and the last element in any work, and mainly in the work we do. We work with models, with science, and with data. So all the tools that I showed are very useful, but in the last instance, data is the ultimate power, or the ultimate value that we can get. Okay, so I think I will stop here. The tools are very useful, but you need to take some practice before you can take advantage of these tools. Maybe it happened to me, okay, that I got frustrated the first 2 or 3 times I tried to use them, but once you learn how to do it, the result is very useful and very fulfilling to produce high quality plots for publications. So I will put these files and some resources in a GitHub repository, and in Discord also. So you can ask me anytime, and we can talk here if you have any doubt, or any question, or any complaint. Yes, I made that configuration files. I will put them in the repository, so you're free, of course, to use them. I tried Okay, I tried many things, many things, until I find the right font and the right combination of sizes and the right distribution of elements in the plot, so that I feel the result is very good. Maybe you prefer some different things, some different details, or something different entirely. It is okay, but I think that the most desirable thing is to produce better results, faster results with less work. So we it doesn't mean that you have to work less. It means that you have to work smarter, right? And sometimes smarter means knowing the right tool or the right tip or the right method or something. So I've tried to mention some of them. I hope you can use it. That's right. Work smarter, not harder. So do you have any question? I thought my time was 40 minutes, actually. Uh, Letty?
Yes, I have a question about, well, the figures and these kind of things. When I have to present in a paper figures and graphics, and always I'm in the same doubt about PDF and PNG, for example. I never understand which is better, which has the better quality and the things. What do you recommend?
Yes, there are two different formats. The PDF, which means portable document format, on the first place is very portable, right? And it is also a vector file. So you can do a great zoom, and the quality of the lines will be always the same. In the other case, in the case of PNG files, it is a vector graphics. Sorry, it is a map bit, a map of bits. Okay, so it is basically a matrix with a different color in each of the cells, and if you make a zoom, then you will start to see the shape of the squares, of the little squares of the pixels. There is one situation in which the PNG is better than the PDF, which is when you make, for example, a scatter plot with a lot of points, with a great quantity of points, or when you plot a matrix, for example, using a color scale. Then in that case, since the number of elements in the PDF file will be a large number of elements, then it is better to use a PNG. In all the other cases, I should say that the PDF is better than the PNG format. And also because using LaTeX, um, we can include a PDF file directly. As you can see here, I put directly the PDF file. No need to change the format or convert to a bitmap file or nothing. Just the PDF, and using PDF LaTeX as a compiler, then the result is optimal from my point of view.
EPS is harder, right?
EPS, I don't know exactly, but I think it is a format which is meant for printers. But nowadays, most of the content are distributed by internet and are seen using screens. So maybe think a format so that it is optimal for printers doesn't make sense anymore. On the other hand, the printers manage the PDF format very well. So I think it is related to the software of old printers, the EPS format. I never use it and I never need it. So I always prefer the PDF format if it's possible to use.
Good, thanks.
Welcome. Any other question? Okay, so this is the end of the FoF. This is the end of the Friends of Friends meeting. Thank you guys for your effort. Congratulations for a great meeting. Sadly, I was not able to participate in all the instances of the meeting, but I know it has been a very high quality meeting. So congratulations to the organizing committee for your efforts and the success of the meeting.
Thank you, Marcel. This was very interesting and very useful for everybody else. Well, thank you, everybody that was attending in this last session at this time. So, well, thank you, everybody. I'll see you soon next year.
See you. Thank you.